Alright, notes 4.2 triangle congruence. Shapes that are rigid they don't change size or shape. So they don't change size or they don't change shape. Alright, or they don't break apart, they stay together. Because triangles are rigid, we can prove triangles congruent by comparing their features. If you're given the lengths of 3 lengths of the sides of a triangle, how many triangles will it make? Well, if we have 3 lengths, we can only make one triangle, only one triangle. And if we're given 3 angle measures of a triangle, how many can we make? Well, here's a triangle. I can make this triangle bigger, smaller, but I'm not changing the angles. The angles all stay the same, I'm just changing the side length. So we can make an infinite amount. So we can make an infinite amount of triangles. So today we're gonna talk about some different postulates to prove triangles congruent. The first one, SSS, or the side postulate. So if the sides of one triangle are congruent to the sides of another triangle, then the two triangles are congruent. So if we have these two sides, this side's congruent to this is congruent to this, and then this is congruent to this, these two triangles have to be congruent. Alright, that's just because if we're given 3 side lengths of a sides of triangle, we can only make one triangle. Now the side angle, side postulate, SAS. If two sides in their included angle in one triangle are congruent to two sides in their included angle in another triangle, then the two triangles are congruent. What this means is that we have these sides, so this side is congruent to this side is congruent to this side, and this is the included angle. See how it's between these two sides? So since it's between them, these two triangles have to be congruent. So they must be congruent. The angle side angle postulate. So if two angles and the included side in one triangle are congruent to two angles in the included side in another triangle, then the two triangles are congruent. So when we look at this, once again, we have these two angles. So this angle is congruent to this one. This angle is congruent to this one. And we have this side is congruent to this. That side length means this base has to be that distance. So if the bases are the same, we also know that this angle has to be congruent to that one. So you have all 3 angles are congruent. And one side length is congruent means all of the other sides have to be congruent. So if we're given the following information, determine if there's only one or more than one triangle that can be constructed. So if AB is 5, so if we have A, B, C, AB is 5, AC is 7, and BC is 10. Well, we have 3 different side lengths. We can only have one triangle. So now it says triangle DEF. So triangle DEF. DE is 14. EF is 12. And angle E is 75 degrees. What do we think? These forms one triangle. Alright, we have two sides and that included angle. Alright, so since we have that included angle, it makes the two sides be 75 degrees. And we know that this has to stop here, and this one has to stop here. So now we have GHI. So GH and I. So angle G is 60 degrees. Angle H is 60 degrees. Angle I is 60 degrees. Do we know how long any of those sides are? So this can be more than one. So, more than one. We don't know how long any of those sides are. JKL. So JKL. JK is 3. Angle J is 45. Angle K is 90. So we have two angles and the included side. So two angles in the included side. Since we have that, we can only make one triangle, because we know that this has to go from here to here, has to be 3, and we set up the angles. So since we have the angles, it's going to tell us where these two lines will intersect. These lines could go on forever, but they're going to intersect at that other point L. So it has to give us one triangle. And then we get to M, N, and O. So M, N, O. M, N is 8. Angle M is 30. Angle N is 110. So once again, we have two angles and the included side. So that'll give us one triangle. And then the last one, we have angle U is 40. So we have U, V, W. So this is 40. UV is 10. And VW is 7. Now with this one, we have two sides and an angle, but that's not the included angle. So it's saying that, well, we have this 10 and this 7, so we can get more than one. This will give us more than one triangle. It'll give us more than one. It'll give us this 40-degree angle. So this 10 and this 7, we're not sure how it's going to look to give us that 40-degree angle. We need to know this angle. So now a couple examples. So we want to see which can be using side, 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 angle, side, or angle, side, angle. When we look at this, angle, 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 angle. So what we get here, are these triangles congruent? We cannot be determined. We don't have an angle, angle, angle postulate, so we need one of these sides. If you look at number 2, we have angle, we have a side, and then we have another angle. So yes, we have an angle, then a side, an included side, and then a second angle. So angle, side, angle. When we look at number 3, well, we have a side, and then a second side, but not the third side. But what we do have are two angles. These are vertical angles, so we have side, angle, side. So it goes side, angle, side. Side, angle, side. With this one, it gives us two angles. Well, we know that the third angle is congruent, but we don't have an angle, angle, angle. But what we know is that this side is congruent to itself. So yes, so we have angle, side, angle. When we look at this one, we have a side, we have a side. It says that these are parallel. So if these are parallel, we know that this angle is congruent to this angle. That's alternate interior. This angle is congruent to this angle, alternate interior. So once again, we have yes. We have angle, side, angle. angle, side, angle. And the last one, we have an angle, we have a side, and then we have a line going down. Well, that gives us a side, and angle, but it's not the included angle. And it doesn't give us any more information about this one. So we cannot determine it. So it only gives us, this would be angle, side, side, which we haven't talked about yet. So now to write our congruency statements, well, we can say that triangle FDR is congruent. Well, F is congruent to W. D is congruent to X, and R is congruent to Y. So triangle LMN is congruent to triangle. We know that L is congruent to P, M is congruent to O, and then N is congruent to itself. Number 4, we can say that triangle FGH is congruent to triangle, well, F is congruent to itself, D is congruent to G, H is congruent to itself. Triangle TRP is congruent to triangle, now T is congruent to angle Q, R is congruent to angle S, and then P is congruent to itself. And number 6, we do not have a congruency statement. And then with the last one, a proof, we'll start to get into proofs. We know our statement, it's the definition of a rectangle. AB is parallel to CD. Well, that's also the definition of a rectangle. Angle ABD is congruent to angle CBD. Well, ABD, that means this angle, is congruent to this angle. Well, that's parallel lines cut by a transversal, alternate interior angles. And then angle A equal and 90, angle B equals 90, definition of a rectangle. AD is parallel to BC, definition of a rectangle. Opposite sides are parallel. And then it says angle ADB. So ADB, that's this angle, is congruent to angle CBD. CBD, parallel lines cut by a transversal, alternate interior angles. BD is congruent to DB, that's this line right in here. Reflexive property means it's just congruent to itself. So triangle ADB is congruent to what? Well, we have an angle, we have a second angle, and then we have a side. So angle, side, angle. So ADB, well, angle A is congruent to angle C. So triangle C, angle D is the purple, is congruent to angle B, which is in the purple. And then B, angle B, is congruent to angle D. So triangle CBD, and we said it's angle, side, angle. So angle, side, angle, ASA. And that was a proof. And we will start to work more with them tomorrow in class.